Right, 2018 C3 has got two questions. Question 4, I've just drawn it out again, so it's exactly the same. It tells you down here that the area of the triangle is 9.8. It's triangle ABC. And this is wanting you to use the formula for triangle A equals a half AB sine the angle between them. So you're told this area is 9.8. AB are just the two sides, so it's 6.9 times 3.4 times sine the angle between them. So my angle is a B, so I'll put a B in there. And what you're going to do is you're going to rearrange this. So you'll bring this 2 across in times, 9.8 times 2. You'll bring these two numbers here across and they both become divide. So 6.9 times 3.5 and you're left with sine B. And if you put that into the calculator, you will have sine B is 0.81159. So just inverse sine on your calculator gives you your B angle. So B is 54.25 degrees. The question doesn't specify many decimal places, so it's standard practice to give it to 3 significant figures. So that'll be 54.3 degrees. Now, that's the angle CBA. Remember, the middle letter tells you where the angle's at, so the angle B. Part 2 of this question is wanting you to find angle CAD. So CAD, I'm just going to call that angle theta. If you look at your second triangle, you will see you only know 2 pieces of information. For you to use the sine rule or the cosine rule, you have to know 3 pieces of information. But if you look at the triangle which links the 2 together, or the side that links the 2 together, that's CA. I can use the information I have to find the side CA. So I know this is 54.3. I'm looking to find CA. When you have 2 sides and the in between angle, you must use the cosine rule. So the cosine rule has AC squared equals the other 2 sides squared and added up, take away 2 times the other 2 sides times cosine the angle between them. When you're putting this into the calculator, do these 2 bits first to give you 59.86. Do this bit next, so 28.2179. Subtracting those, you get 31.6421, and then square it at the end, 5.62507. Now, I am able now to move on to that second triangle. So CA, I've just found AC, so 5.62507, and this is 28. I'm looking for this angle, and 11.6. I can see the sine rule here because I have got the side over sine the opposite angle equals a side over sine the opposite angle. Whenever you have a fraction equals a fraction, you cross multiply. So it's 5.62507 times sine theta equals 11.6 times sine 28. I'm going to bring this over to our side so it becomes a divide, and just popping it into the calculator. Sine theta 11.6 times sine 28, press the equal sign after you do that, divide it by 5.62507, should give you 0.968. You go inverse sine, and you can see me starting to do the cast diagram here, because you were told that sine or the angle was obtuse. So I'm in this quadrant, because obtuse means between 90 and 180. The principal angle here is when you work out inverse sine of that, so 75.5 degrees. I want this angle, so to find it, I will go 180 minus 75.5 to give you 104.5 degrees. So angle CAD is 105, giving it to 3 significant figures. Another question from that paper is question 6. If I just scroll down to find it. So 6A, quite a straightforward one. prove that this equals tan. So if you write out the formula, or sorry, the expression they give you, times out the top line, so 1 plus cos minus cos squared all over sine cos. That is 1 minus cos squared over sine theta cos theta. Now, one of the rules that we're going to be using in here is sine squared plus cos squared equals 1. So using sine squared plus cos squared equals 1. I could rewrite that as sine squared equals 1 minus cos squared. So 1 minus cos squared is sine squared on that top row. Sine squared over sine cancels to give you a sine on the top. Got cos on the bottom. Sine over cos is tan theta, which is what they were asking for. Part 2 of this is a hence. So I'm going to use my previous answer. So instead of writing out this left-hand side, I'm going to write in there tan theta, because that's what I've shown it equals. Equals 2 tan squared. It's quadratic, so everything goes on one side. So tan squared plus tan theta minus 2 equals 0. You can use quadratic formula, or you can factorize in here. Tan theta minus 1, I'll use factorizing. Tan theta add 2 equals 0. So I'm going to have two answers here. One of them, tan theta equals 1, and the other one, tan theta is minus 2. So find your principal angle. So inverse tan 1, my principal angle over here is pi over 4. On this side, my principal angle is inverse tan 2. Remember, always find the principal angle of the positive, and that's 1.107. If we look at the question, it's wanting it in radians between 0 and 2 pi. So drawn out the wee cast diagram between 0 and 2 pi. C-A-S-T. Tan was positive, so it's these two quadrants. Put in your principal angle going from the horizontal. So you will get theta to be pi over 4. And this one here is pi plus pi over 4. So 1 plus a quarter is 5 over 4. So 5 pi over 4. And on this side, again, it's the same cast diagram. And 2 pi, C-A-S-T. This time tan is negative. So it's this one or this one. And remember, your principal angle always goes from the horizontal. So your two answers in this side are theta equals pi minus 1.107. And the other one is 2 pi minus 1.107. So this one here, we just put it into the calculator. So pi minus 1.107 gives me an answer of 2.03. And the second one, 2 pi, take away 1.107, gives me an answer of 5.18.